Thank you, Niels. And again, good morning to all of you, or good day, good afternoon, wherever you are sitting. I feel honored that you invited me to present as the first this morning to you. I'm normally used to do that for ABLOS in a way that I try to illustrate the interrelation between what you call ocean geoscience and the legal questions which those disciplines pose to us. Actually, I had difficulties to do that properly in this format. So I hope you can accept if I this time focus more on the maritime geoscience in itself, and we postpone those questions resulting from to the legal domain to the next physical meeting. The motto is future decade is past century and future decade, and you are well-educated people know that the past is the only source for humans to learn about themselves, finally. So, and therefore, I thought I would simply start with a video which we were producing by event of our centenary celebrations on the 21st of June this year, which was likewise a hybrid event. So we had a local reception here with His Serene Highness and other celebrities from the region, but likewise we had a digital component to outreach our message and to present how hydrography, and in particular international collaboration in hydrography, has developed over the last 100 years. So what I try to explain is exactly that. That these celebrations offered us the opportunity to highlight the achievements, the enduring relevance, and likewise the future of hydrography, and that really complies very much with the motto of this webinar. And historically, it was so that the IHO was established under the impression of the SS Titanic catastrophe, and there was a collective aspiration to make navigation safer. So historically, our focus was on a coordinated approach for nautical publication and nautical charts and sailing directions. This has been used on a global scale, and that gave a really excellent example in the early beginnings, what we now call geoscience. So the tendency to standardize that cross-border and even for countries which were not necessarily friends, to say it gentle, that was really setting a standard, not only in a technical sense, but likewise in a sense of collaboration. So, and that is still the main aspect of our work. But what we can really see, and I think that is the lesson we are learning for the future, for the upcoming decade, is that hydrographic information is useful for many, many more stakeholders, and I listed here some of them: shoreline construction, cable laying, pipelines, and so on and so forth. And that will, by all means, shift the focus of our undertakings within the next 10 years. Data centricity is a key word for that, and that, of course, will finally result in new questions with a legal background, and you know, we have had discussions on maritime research in EEZ and in territorial waters if this needs allowance, so on and so forth. But I can really now do what I promised. I will start the video.
The early 20th century highlighted the importance of international cooperation and ocean mapping. This led to the creation of the International Hydrographic Bureau in Monaco in 1921 upon the invitation of Prince Albert I. Now known as the International Hydrographic Organization, in 2021 it has 94 member states. The IHO's work has evolved in parallel to changes in technology and member state needs. Early surveys were carried out using lead lines and sextants. With the introduction of GPS in the 1980s, global positioning made a quantum leap in accuracy, which in turn led to increasing accuracy in maps. In parallel, the IHO assisted in the development of hydroacoustic survey methods. The 1990s saw the introduction of forward-looking sonars, multi-beam echo sounders, and the first digital maps. The IHO Transfer Standard for Digital Hydrographic Data, S57, in 1992 was a key stepping stone for the widespread use of digital data and computers in navigation. This resulted in the first mobile computerized navigation devices, the Electronic Chart Display and Information Systems, ECDIS. Thanks to globally harmonized data for electronic navigational charts, ENCs, these are now used by all ships on international voyages.
With over 17,000 electronic navigation charts across the globe and the standardized international paper chart series, these are the most successful governmental standards for marine geoinformation.
More recently, the introduction of autonomous vehicles and drones are facilitating surveys in remote or potentially dangerous areas. They can collect data for large areas quicker than a single ship and at higher resolution, especially in the ocean depths beyond the range of surface systems. Today, hydrographic data is used in many areas: fisheries and aquaculture, marine renewable energy projects, as well as baseline data to monitor the impacts of climate change. The IHO has evolved over the years and provides a forum for member states and international organizations to come together and address important issues. One of the most significant collaborative programs is the General Bathymetric Chart of the Ocean, GEBCO, a joint program of the IHO and the Intergovernmental Oceanographic Commission of UNESCO, IOC. Launched in 1903 by Prince Albert I of Monaco, it is still widely used, and together with the Nippon Foundation GEBCO Seabed 2030 project, it aims to provide a complete picture of the seafloor. Already, we have progressed from having a map of 6% of the oceans in 2017 to 21% in 2021. With the IHO Capacity Building Programme, which has assisted in education and training within member states, citizen science initiatives and more, the history of the IHO is a story of successful international cooperation in hydrography, and it will continue this important work in the future.
We are producing the most successful international standardization for geoinformation, and that in particular autonomous technology is about to change the setting completely. As you can see, all those utilities are unmanned and remotely operated, and that will be a significant change from the IHO perspective. And though the IMO is discussing again and again how autonomy in shipping can be regulated, hydrography hasn't solved the problem, but autonomous operation in hydrography is already a fact of life. It actually really exists, and it is in daily use, and I have every confidence that it will subsequently replace a relevant percentage of the survey operations at sea. So we will say lesser and lesser manned survey launches in operation, but more and more autonomous units. And the interesting case is that in our domain, life is stronger than legal regulation. I'm not 100% sure on what basis those autonomous units operate, but again, the fact is they simply do. So that will be an interesting aspect to cope with in the future. And it's not too long ago that Indonesia was hosting a workshop on that subject, and I'm not in the position to recap what have been said there. But nevertheless, I recall there was one aspect that they had an intruder in their territorial water, so that an unmanned survey unit entered Indonesian waters, and it was not clear from which country it came. Nobody phoned and asked for the one. So we are facing interesting question on those subjects in the future, I suppose. Anyway, again, it's difficult to explain those things remotely. I continue with my presentation. Technical standardization is relevant, but we also need qualified people to carry out hydrography, and that's the second main pillar, or has become the second main pillar of the IHO. We assist member states in building capacity, and over the years we have hundreds of students that have learned the principles of hydrographic survey and sea cartography, and they already span a great network of alumni. Larry Mayer would be the most prominent man to witness that, since the University of New Hampshire is very proactive in this sort of education, and the great benefit which our discipline enjoys from the network of those young generation. They really educated from the cradle on the principles of collaboration. This is wonderful to see how they behave, and they have to, as we all know, that they face great challenges in many respects, not only because the technology is so rapidly evolving, but their task at hand is really to reconcile the sustainable use and the preservation of the marine resources, and that couple is easier expressed as to be done, sustainable use and preservation at the same time. With that, and I tried to express that already before, that hydrography, in our understanding, is based more when doing bathymetry, when measuring the water depth. So, and the phrase I coined to get a grip on that is to say, hydrography is on the measurement on all the physics of the seas, and the means to distribute those information and to make a better use of that is what we call IHO's S100 Universal Hydrographic Data Model, and that enables the merger of data of the physics of the ocean. And this is not limited to topography. It is also sea level, tides, current, and other parameters. But the really great step forward would be if we could merge that with other ocean data. Because to my impression, this is still the case that those disciplines like marine chemistry and marine biology, they move on in parallel, but we have still too less interconnection between all those domains. And the key for me is data standardization, and the buzzword for that, if you want, is interoperability. So we should make those data stocks technically interoperable so that you can mesh up whatever you want to get new insights. That's the technical aspect, but that has an effect on the question, what is hydrography about? So it can now become more encased into what is in the water. And I started to say that to provoke some responses from the oceanographers, because so far I have the impression that the oceanographers to some extent believe that the question, what is in the water, is within their domain. And that poses the question to me, where is the separating line between hydrography and oceanography? So my interpretation is that hydrography provides the measurement of the observable natural effects. That's what we do by means of engineering. And oceanography delivers the scientific explanation of the observations. So following by creation of the greater picture for nowcasting and forecasting. So it's debatable who is the smarter, those who do the measurements or those who provide the later explanation. But in order to address this new quality in the conduct of hydrography, I propose that we use something like spatial hydrography, which indicates that we do not work in two dimensions, not only working on the topography of the bottom of the seas, but have anytime we do hydrography, we take the water column in our mind as well and have a holistic understanding of the area as two dimension as well, to the cubic, if you want, to the space we are working. I was asked, and that turns now, or maybe other way around, maybe what I was presenting so far was the lessons learned from history, but to make it productive, we must ask ourselves, what is the essential outcome for the future decade? What is what we want to actually see to arrive in the next 10 years? So, and I tried to do an interpretation from the IHO's perspective. I, as being the Secretary General, I have a shared role, and on one hand, I'm the Secretary of the Member States, and I in place to conduct a collective will and aspirations of the Member States. But on the other hand, I know that some expectation that I propose a way forward, and then Member States have a chance to discuss and to say if they agree and want that adopt to their collective aspirations. So here's my list of proposals. So based on S100, we should have a fully new generation for electronic navigational charts, and we need to collaborate with the IMO to make it the default format for electronic chart systems. I see smart underwater laser scanning, which will hopefully amend the classic hydroacoustic portfolio for in situ basic measurements. We will see that on autonomous carriers, but we already see that if you want. Artificial intelligence will help us to get smarter results out of hydroacoustic data, and we will have a merger of hydroacoustic laser scanning and satellite imagery. And that, as I tried to say before, to express before, is would not only affect the ground, but the water column will come more and more in our focus. What we desperately need is wireless underwater communication, broadband communication under the surface. This is still a dream. And if you ask me which sort of physical principle could provide that, then I must say, unfortunately, I do not know. But as communication is the key on land side for the evolution of all technical processes, I think so would it be under water. So it would give a great boost, and one day someone will come up with a smart idea how to do that. And I hope that will happen in my time of service next 10 years. Yeah, then I was mentioning the all-embracing digital representation of the ocean based on the IHO framework. So the phrases used for that is the digital twin of the oceans. And I was used to say sometimes the digital aquarium. Unfortunately, this phrase was not adopted by others. But it addresses mainly the same aspect, that we find a way to holistically mesh up all the information we have and to get out new insight, which we couldn't gain once we look at it in digitally separated disciplines. Then my newest idea is that we could collaborate with the ARGO program, because the reality of life, and I come back later to that as well, our topographic knowledge of the ocean is still sparse, and in theory, ARGO floats could help us to complete the image of the deepest trenches of the oceans, because they do groundings, and I'm in an ongoing conversation with the ARGO people, in particular, some who sit in Tasmania and Hobart to find ways to extract the depth data from ARGO groundings. And there's one more thing which I have tabled many times before today. I strongly believe that microplastic monitoring shall become a regular task of hydrographic offices. I don't see any other global infrastructure which has a capacity to do that in situ, systematically, repeatedly, on a regular basis. Don't mix that with the official IHO program. Those are my proposals and ideas for the next 10 years to come. And finally, and I put that at the last bullet point here, because I would give 2 more slides for that. The JEPCO program, in collaboration with seabed 2030, should hopefully arrive to full global bathymetric coverage in decent accuracy and resolution within the forthcoming decade. For JEPCO, and I think it doesn't need to explain that in detail to you. The JEPCO program was established in 1905 as one of the longest running and everlasting program. You may be familiar with that image, and some may believe that we have full knowledge of the seabed topography of the world's oceans. Unfortunately, this is not the case. This is the underlying databases we have. So, and you see the the yellow tracks, this is multi-beam. We have some single beam, and we have compilations, and this is good for European waters around Australia and east from Japan. But the dominant color is black, and black means we have no data. So there's nothing. We don't know. We for 80%, nearly 80%, we live on a continent where we don't know the ocean's topography. So this is really impossible to tolerate, but that sets the scene for the task at hand to change that within the decade. And we have to get access to any source, and one source is crowdsourced bathymetry. Some may call that citizen science, and that, without telling you too much about the technology, I can report that the relevant working group of the IHO had a meeting just recently. We have growing participation of industry and academia. They jump on the train. They more and more understand that can be a business case and a research case as well. And what is in our remit as organization is to pave the way for the acceptance of the coastal states, that while ships on passage are allowed to gather and collect those data for the purpose of transmission and later incorporation in the JEPCO grid. And that's difficult enough. That's difficult enough, and so far we have 30 IHO member states who have indicated allowance of that. And this is only, those are the first 4 of those 30 out of 95. And you see out of 95, which and you see they put different caveats on your allowance to do that, and that doesn't make things easier, I must admit. So there is some work on our side to convince coastal states to allow this and give more freedom to those who are willing to support us with their data collections. Yeah, that's I think in a nutshell what I was about to present to you this morning. I would not end up to praise the capacity of ABLOS to identify new regulatory aspects in the changing environment. That's exactly what we need. And your talent, in my view, is that you bring administration, that's me to some extent, industry and academia together. I have a lively recollection to your last conference now 2 years ago. That was exactly what has happened here. And I think we can all unite behind this greater vision of our time to use marine resources cautiously and wisely, to preserve the portions of the marine environment which are still intact, and to repair the damages made. So this is the vision of the next decade, in my view, the greater one. And everybody is playing his role in that, and not to the least, ABLOS has a role here as well. We were honored by a visit of Peter Thompson, by event of our 100 years celebration, the UN Secretary General, Special Envoy for the Oceans. And he was saying, hydrography is called to provide the data we require for the science we need for the oceans we want. And that's exactly what I would like to convey this morning to you. Thank you for your audience.